Start recording. Let me start the recording. Yeah. So one request from my end. Okay. So people that has joined from Sunad Technologies. So since if your link has terminated, okay, so the session is closed. Please try to rejoin it. Okay. Please try to rejoin it, and I would immediately. Okay, so I would immediately start the session. I don't know, sometimes the session is automatically being terminated. So hope you understand that. So please try to rejoin. Just refresh that particular link. Okay, that particular tab that you have opened, and you would join to the session. Okay, so small request from my end. Okay, yeah. So shall we start? Yeah. Okay, so first of all, what is data warehousing? So, data warehousing is nothing but how to maintain a data warehouse. Okay. So, what is a data warehouse? Data warehouse is a relational database that is designed to store a massive amounts of data. Okay, the data is historical data and aggregated and cumulative data that is derived from the transactional systems. Usually, multiple systems you would have. Okay, so from these multiple systems, okay, so like that can be the SQL based RDBMS okay, so transactional systems. Okay, that can be your NoSQL databases. That can be any kind of SaaS based platforms like Salesforce and this CRM, CRPs like that, or it can be either flat files where that are present in a some kind of FTP server like that. So here, um, data warehouse is a place. It's a relational database where you are going to store the massive amounts of data that has been extracted from these different sources, okay, and transform the data. Okay, transform the data. So that means the data accumulation and data aggregations, and data cleansing and transformation, all these things you are going to do. Okay, all those things you are going to do upon the extracted data from multiple sources here. And finally, maintaining the data in the data warehouse. Finally, maintaining the data in the data warehouse. Okay, so this data that you are maintaining in this data warehouse is used to query and analyze the data. Okay, in order to make some data driven decisions, in order to you are going to perform the okay, your company or your other teams, analytical teams like business intelligence teams, reporting teams, data okay, so data science teams, machine learning engineers, those are going to use this data in order to do the predictive analytics, prescriptive analytics, okay, descriptive analytics, like this kind of, there are multiple types of analytics are there. So that would at the end of the day, they wanted to use this data in order to improve their business. Okay, so that means by using the data that you are stored here, by using the historical data plus transformed and aggregated data, you are going to perform the analysis. Okay, you are going to perform the analysis that would make, okay, that would make some data recommendations that would help the business people to make some data decision making on how to improve their processes, how to improve their operations at the customer's end, and that kind of process. So here, in order to do this, so in data warehouse, essentially you are storing a transactional data over a period of time. Okay, over a period of time, and use the data in order to improve the transactional process only. So it's a cyclic operation. So you are going to extract the data from these different source systems. Usually that are these systems are going to be representing how your client is performing the business. Okay, how your client is performing the business. So each transaction that is happening at a business level is converted into a data and stored in this transactional systems. Okay, in this transactional systems. Okay, once the data is here, periodically you are going to extract the data. Periodically you are going to extract the data. So transform it. Okay, transform it. So here transformation include data cleansing, doing the data aggregations, and okay, so lots of steps are there. So transforming the data and finally load that into a data warehouse where you are going to have the data that belongs to multiple years. Okay, multiple years, and finally use the data in order to do the analysis on that. So here, this particular framework that you are seeing is a ETL process. This kind of process is suitable for a small to medium scale of data, small to medium scale of data. But with the emergence of big data, with the emergence of big data, okay, so there is a process called ELT. So since uh, big data is defined by, okay, big data is defined by 5 v's, right? So what are those? Can someone tell me what are those 5 v's? 5 v's. Okay, so volume. Okay, first v is volume, velocity, variety, okay, veracity, and value. Okay, so that means you are generating a huge amounts of volume nowadays, and the data is being generated at a high velocity. And nowadays, you see, business are generating the data in different formats. Usually data can be classified into three formats: structured, semi-structured, and unstructured. So structured data is nothing but a tabular like structure, whereas semi-structure, it has some kind of traditional, it has some kind of structure, but not the traditional structure like rows and columns, but it has some kind of structure like Parquet, JSON, XML. These are considered as semi-structured data. And there is unstructured data. So unstructured data is nothing but some like audio files, video files, images, and that kind of sensor generated data, and all of that are considered as unstructured data. So nowadays organizations are generating a huge variety of data, and this veracity and velocity determines the how much value that you are gaining from that particular data and all of that. Okay, so since emergence of big data, so that this ETL process cannot able to scale in order to meet the requirement. So for that, okay, so there is a emergence of okay, so there is a emergence of ELT process. There is a emergency of ELT process. So this ELT process, you are going to extract the data from all these sources and directly load the raw data into your target system, that which is a data warehouse. Okay, so here you are going to do the transformation part. Okay, here you are going to do the transformation part. Usually ELT process is used on cloud based data warehouses, because the cloud is known for its scalability and its elasticity. Okay, so based upon the requirements, it can able to add up the additional resources that is required, right? So because of that, because of the emergence of big data nowadays, people are making a transition from the ELT framework to ETL framework to ELT framework. Okay, so that means transformations are happening inside the target system. Transformations are happening inside the target system. I hope you get the difference between what is ETL and what is ELT, right? So here you are going to extract the raw data, that means the source formatted data, and load it directly into your data warehouse. And inside this data warehouse, you are going to do the transformations as per the business requirements. Okay, after doing those transformations, you are going to store the data in the final consumption layer. So that consumption layer data is used for analysis purpose. That consumption layer is used for analysis purpose. Okay, so that's how like the data warehousing has been transitioned from ETL to ELT. Okay, so here, in simple words, we can say that data warehouse is a centralized repository in order to store the historical and aggregated data, okay, that has collected from the multiple transaction systems, in order to query and analyze the data. Okay, in order that would help you in the process of decision making. That would help you in the process of decision making, rather than the performing operations. Okay, but rather than the performing transactional operations. Okay, so that's the main goal of the data warehousing. Any questions regarding that? So if you have any questions, please try to interrupt me, and let me address those issues. Okay, so this data warehouse is going to have some kind of characteristics. Okay, so this data warehouse systems is broadly have this kind of characteristics. That is, whatever the data that you are going to store here in this data warehouse, it focus on a particular subject rather than the doing the company operations. So for example, the sales data, marketing data, or kind of supply chain data you are going to you wanted to maintain. So that kind of whatever the data that related to that particular subject you are going to maintain here, you are going to maintain in data warehouse. Okay, so it helps you to focus on modeling and analysis of the data in order to make some better data driven decisions. Okay, and whatever the data that you are going to maintain in this data warehouse is integrated from, it integrates the data from multiple sources. Okay, so whatever the data that it has extracted from these sources is going to be transformed into a consistent format, so that your data warehouse can able to, so that your data warehouse can able to store the data in a unique way. So here the consistent means in terms of naming conventions, in terms of data format, and in terms of how the data is being encoded also. Okay, so all of this in terms of the uh, how the data that is being extracted from multiple systems, you are getting them into a consistent and unique format, into a singular format, into a singular consistent format. So in order to store the data in the data warehousing. And the time variant. Okay, so since you are going to maintain the data, historical data. Okay, so you are going to maintain the historical data. Okay, so here you are going to store the data that has been generated over the past years. Okay, so this helps you to focus on the how business is performing over the period of time. So it provides you information about, provides you in order to perform how the business trends has been looking, and how the changes would impact a particular business operation, or in order to do the forecasting kind of predictive analytics kind of thing also. This kind of historical data is essential. Okay, so this time variant, since you are going to maintain the huge historical data, that would help you in order to understand the trends, in order to detect some kind of okay, detect in some kind of similarities, okay, over the past years, in order to forecast how it is going to perform in the future. Like this is called predictions, right? So forecasting and predictions you can able to do. Okay, so for that, whatever the data that you are maintaining in data warehouse, it is going to maintain in a time variant format. Okay, and whatever the data that is maintained in this data warehouse is persistent. Okay, and non-volatile. So non-volatile means once the data is stored in the database, it does not change, right? It does not change. Okay, so whatever the new data that comes into here, it does not delete the existing data, it is going to be created as a new data. Okay, so whatever the data that is already present, it does not need to change, it does not change once the data comes into warehouse. Okay, so when new data comes, previous data is not erased, only the new data is added to the data warehouse. Okay, so in because of that you are going to have build pipelines as as a data warehouse developer or a data engineer. You are going to build the pipelines that would periodically refresh the data that present in data warehouse by extracting the data from multiple source systems, and maintaining the data okay, consistently in your data warehouse that has time variant data. So that is going to be uh, considered as integrated data from all of the source systems, and that would focus, each database would focus on a specific subject. Each database would be focused on a specific subject, like sales, marketing, supply chain, like this kind of thing. Okay, like this kind of thing. Okay, so for any data warehouse, these are the characteristics um, that you would expect. Okay, so these are the characteristics it would have for the data that you are maintaining in a data warehouse. Okay, so here we have talked about what is data warehouse and what kind of characteristics the data should have in order to store it in a data warehouse. Okay, so coming to next ideal features that any data warehouse platform would have. Okay, so organizations build the data warehouse in order to store and centralize massive amounts of data across that has been generated across their organization. In order, the goal is here to perform the analytics and reporting on the data so that it can help the business people in order to make some data driven decisions, right? Informed data driven decisions. Okay, so that's we already discussed. Okay, so here, in order to store this historical data, in order to design a system that can able to analyze the data, so it should have certain kind of features. Okay, it should have certain kind of features. So the first one is that database platform should able to exhibit a strong performance that would support the fast user experience, because here you are going to store huge amounts of data. Whenever you run a certain query against that particular database, okay, so it is going to process that huge amounts of data, right? So huge amounts of data. Okay, so that means your query should run quickly enough so that the end users won't end users won't feel that the query is getting delayed, and it don't experience some kind of timeout kind of issues. Okay, so because of that, the your data warehouse platform should exhibit a strong performance that would support the fast user experience. Next, your platform should have a on demand scalability. Okay, so this is where the on-premise systems are failing. On-premise data warehouses are failing. So in order to scale on the on-premise, you need to take the system offline. You need to add the additional servers, and you need to do the data shuffling between all of these new clusters, and then make make that system go to live. So that this would take, okay, um, this would take several hours to several days. Okay, during this time you are going to experience the outage of the data warehouse. Okay, so you need to have a system that can able to support the on demand scalability. That means whenever the additional resources are required, your system, your platform or system, your data warehouse system can able to provide those additional resources. Whenever they are not needed, these additional resources, automatically it should deallocate those resources. So your system must have a scalability. Okay, your system must able to exhibit the scalability and also the elasticity, okay, that is needed in order to handle the any kind of workload that is going to be running on that particular data warehouse platform. Okay, so and your system must able to support all the data formats, because now in today's requirements, the organizations are generating the data in all sorts of formats. And you know that in order to make the data available for the analytics teams, you need to maintain the data either in data warehouse or data lake. Okay, so data lake supports all the formats, but if you wanted to maintain the data in data warehouse, your data warehouse platform should support all the structured data formats, semi-structured, even you can able to store the unstructured data also in your target system. Okay, so should able to support all the data formats. And very importantly, you should able to query that semi-structured data or unstructured data by using SQL syntax, okay, if it is possible, then that would be great, right? So in current day market, any data professional, what is the basic skill they would have is SQL. Okay, so earlier days, if you wanted to convert that semi-structured data into a structured data, you need to use the high level languages like Java, Scala, Python, these kind of things, and convert that semi-structured data into a structured data, and then you are going to load that data into your data warehouse. Nowadays, so with the a with huge velocity, you are generating a huge amount of data, huge volumes of the data. So you should that kind of ETL process is not relevant in the current market, right? So as soon as the data is being generated, you should able to extract the data and load it into your data warehouse platform, load it into your data warehouse platform. So in order to do that, your system must able to support the semi structured and unstructured data formats, right? Okay, so for that, okay, that is the reason why your system must able to have a schema on read kind of policy, schema on read kind of policy. Okay, so and in order to query the semi structured data by using SQL, okay, so your system must able to provide some extended SQL functionality that would help you to directly query the semi structured data. Okay, so this is very important feature now that is lacking with lot of traditional data warehouses. Okay, and because you are going to maintain huge amounts of huge volume of data, that since it's a data warehouse is known for a repository for historical data, so huge amounts of data is stored and you are going to process this huge amounts of data. Your data warehouse platform should be cost effective, that would have unlimited scalability and elasticity in order to, okay, to store the data, in order to process the data. Okay, so and also very importantly, this is the one of the main issue that other all the traditional or legacy data warehouse is having. So there is a limited concurrency. So your data ideal data warehouse should have can able to provide unlimited concurrency in terms of workload concurrency, in terms of user concurrency. So what is the workload concurrency means? Let's say on a data warehouse platform there are tens of teams that are working on, okay, tens of the teams that are working on, so no other team should interact, should fight for the resources with the other team. So there should be no resource contention between these teams. Okay, between these teams, that is considered as workload concurrency. So let's say the data engineering team should not fight for the resources with the data analysis team. Okay, and similarly, whatever the data applications that is feeding of the data that is present here in the data warehouse should not able to hoard the resources in order, okay, should not able to occupy these compute resources. Okay, so that other teams cannot able to access it. So because of that, you cannot able to achieve the consistent SLAs that has been promised, right? So here your data warehouse can able to have a workload concurrency. That means different teams can able to work on that particular platform at the same time, and also in each team there is hundreds of users or tens of users, all of them can able to work and query that the data that is present in the database. So that is called workload concurrency and user concurrency. So this, which is a very important issue that is present in the legacy traditional data warehouses. Okay, and finally, all of this should be present in a near zero management system. That means coming from the provisioning of the resources or provisioning the users, making the data availability, performance tuning, the data protection, or any other kind of operations that you are performing. Okay, so that would take in the burden from that would take the burden from database administrators or data operations or DevOps teams, data ops and DevOps teams. So your system can able to handle some kind of automation, okay, in order to handle all these kind of activities. So whenever a data warehouse platform has these features, then that is termed as a ideal data warehouse. Okay, ideal data warehouse. Okay, and Snowflake is the first data warehousing solution that is present in the market that supports everything that is listed here, that supports everything that is listed here. Okay, so this is the data warehouse evolution. Okay, so first, from last 30 to 40 years, where you are using building the data warehouses. So okay, initially we used traditional RDBMS based systems like Oracle SQL Server, okay, in order to maintain the data warehouses. Till current day, there are some customers that are using these Oracle based data warehouses, SQL Server based data warehouses. And in early 2000s, there has been massive growth in the appliances based data warehouses. So because with the emergence of massively parallel processing architecture, so like shared disk and share nothing, so there has been lot of appliance based data warehouses that come into picture. That is Teradata, I, IBM's Netezza, Oracle Exadata, and Vertica. This kind of data warehouses has been coming into picture. Okay, so that would process the queries in parallel way. That would process the queries in a parallel fashion way. So that's why these appliances based systems are called as massively parallel processing, MPP based data warehouses. MPP based data warehouses. And in late 2000s, the evolution data warehouse evolution has come to the distributed platforms like Hadoop platforms. Okay, Hadoop platforms. Okay, so here in this Hadoop ecosystem, the data how the data is stored is in a format called HDFS format, Hadoop distributed file system. Okay, Hadoop distributed file system. And Hive is the, okay, data warehousing service that you do have in Hadoop ecosystem. Okay, so here what is the one drawback with this Hadoop is everything is managed by the customer. That means coming from the infrastructure to configuring those all those servers, and managing those servers, and keeping up and running those servers, and everything is handled by the customer itself. So because of that, that particular customer that has implementing the data architecture on the Hadoop has to have lot of skilled resources, ranging from system engineers to uh, data engineers. Okay, data engineers, analyst engineers, data science teams, and all of this. So there is no okay, so there is very scarcity for that kind of resources, right? So that is the reason why many of the Hadoop projects are failing. In 2019, there is a Gartner report called, okay, there is a Gartner report that states that 85 to 90% of the Hadoop projects are failing. Why? Because there is a huge burden on that customer in order to maintain everything by themselves. Okay, so even there is a Hortonworks, Cloudera, this kind of services has came into picture, but with the emergence of lot of new open source tools, and there is a lot of confusion which one would provide the better kind of services, and consistently there is a new kind of services that comes into the market with the okay, so with the upgrades and everything. So in order to keep up with the technological enhancements, so it has become very difficult for the customers to maintain their data platform on the Hadoop architecture. And in early 2000s, from 2012 to 2012 onwards, there has been emergence of the cloud based data warehousing solutions. Okay, cloud based data warehousing solutions. So you know that current day there are three major players in the cloud market, that is AWS, Azure, Microsoft Azure, and Google's GCP, right? So Amazon AWS okay, so provides this data warehousing solution on the cloud via a service called Redshift. And similarly, Microsoft is providing cloud-based data warehousing solution as earlier it is called as SQL Warehouse. Now it is called as Synapse Analytics. Okay, Synapse Analytics. And from Google Cloud there is a BigQuery. From the Google Cloud there is a BigQuery. So even these cloud based data warehouses also a lot of shortcomings, that when they are released, none of these are based developed for the cloud, Okay, cloud architecture. So none of these are designed explicitly for the cloud, designed explicitly for the cloud. So they have this Redshift has the basis, okay, has the roots on the database called Parakeet. Okay, so this Azure SQL warehouse is having the roots on SQL Server, and this Google BigQuery, when it is released first, it's entirely a new system. Okay, so only Google people know how to use it, and it's not much user friendly and all of that. Okay, so because of that, there is a major backlash regarding the BigQuery version 1. In 2018, Google has released BigQuery version 2, and it is much better and much can be there are a lot of features that still compete with the Snowflake. Okay, if there is any data warehouse that would come mm, equal to the performance and simplicity, that is the BigQuery. Okay, so like that, initially cloud based data warehouses has been offered from first Redshift has come into picture. Later, Azure has released this, and next, Google has released BigQuery. Okay, so in that time, Snowflake has been founded in 2012, and they reimagined every aspect of the data warehouse so that they can able to build a database architecture that would suit for the cloud. Okay, that would suit for the cloud computing. So that means they have completely, okay, build Snowflake from the ground up. They have reimagined every aspect of the data warehousing. They have implemented a new database architecture, okay, that would complement the cloud computing. So like that, Snowflake is the first data warehousing solution that is designed by keeping cloud computing in the mind. Okay, so Snowflake has been released to the market in 2014. From then onwards, currently Snowflake is having nearly, I think, okay, from last time I have seen, it is 6,800 plus. That is almost 8 months back. Okay, okay. So currently, it should have customers nearly 7,000 plus customers, and in Fortune 500, there are 300 plus Fortune 500 companies that are implementing data warehouse on Snowflake. Okay, so you can see how Snowflake is providing a huge competition to this cloud-based cloud. These cloud providers provided data warehousing solutions. You see, out of Fortune 500 companies, more than 60 to 70% of the companies are implementing Snowflake for their data warehousing requirements. So that much of huge popularity. Why for the Snowflake is its simplicity. It's a unique way of handling the data and managing the data within its platform, and also some other few things which we are going to discuss in the coming slides. Okay, so over the period of last 30 to 40 years, this is the evolution that is happening in the data warehouse market. Okay, so there is if you go to the if you ask anyone that is present in working on a Snowflake, so majorly a lot of them are migration kind of projects. So that has been migrating from Oracle or SQL Server, Teradata. Okay, so on Teradata, Netezza, and this kind of thing. Netezza, I think it is decommission. IBM is decommissioning the Netezza from next month onwards. I don't remember the exact date. So IBM is like discontinuing its services for the Netezza. Okay, so like that, there are huge number of migrations that is happening from these systems. And even there is, I have seen projects that has been migrating from Redshift to Snowflake, Azure to Azure Synapse, or Azure SQL Warehouse to Snowflake. Okay, so uh, you are going to work, most probably you are going to work for a migration project. Okay, so migration project that is migrating the data from these systems. If the migration phase is completed, there is the second phase of the development. So redirecting the sources from your legacy data warehouse to Snowflake. So that most of the projects are live at this stage only, either first phase or second phase. Okay, so this course would make you established in all those two okay, so two kinds of projects. Okay, so you can able to comfortably work with that two kinds of projects. Okay, any questions? Yeah. Yeah, so basically, in order to learn Snowflake, you need to have just SQL knowledge. Okay, if you are intermediate level proficiency on SQL, that is sufficient. But if you want to get better opportunities, then having the ETL knowledge, ETL basics would be uh, very much appreciated. Okay, so uh, any kind of ETL, not recommended one kind of ETL or like that. So any kind of ETL is recommended. Okay, so whether it can be like informatica, talent, abincio, like these kind of things, or the older ones, okay, or new generation ETL tools like Matillion, Fivetran, AD, Azure Data Factory, like these kind of things also. Having basics of ETL would be like your profile would add okay, like 20 percentage of weightage, additional 20 percentage of weightage. Yeah, in order. Okay, okay, okay. Yeah, definitely. Definitely, there are a lot of opportunities. Okay, in this course, we are going to talk about not only Snowflake, we are going to talk about some SQL. Okay, we are going to talk not SQL. Okay, the cloud related concepts. Okay, so I would tell you what kind of additional things that you need to prepare for yourself on the cloud front, and in order to give you some kind of basics also, the Matillion we are going to cover like 3 to 5 hours. Okay, so many people don't have the ETL knowledge. So what kind of activities that you usually perform, and using that Matillion ETL tool, we would like I would show you a way to connect with the. I would show you a way to connect with the on-premise databases or cloud RDS. Okay, so and how to extract the data. So both in full load manner or incremental load manner. Okay, so that would give you some kind of basics around that, but you need to get explore on that. Okay, hope. Yeah. Okay. Yeah, please. Yeah, Snowflake supports ACID transactions. Yes. So yeah, so Snowflake has a service called transaction management. So every statement you are going to run is going to be compliance with the ACID requirements. Okay, so yeah, so Databricks has been offering the same kind of services more or less. Okay, so Databricks has recently offered a service called Lake House, where you can able to build data lake and data warehouse on the Databricks platform. Okay, so Snowflake has been doing that for much earlier than the Databricks, and whatever the features that you have in the Snowflake are much matured and less prone to errors and that kind of thing. And the simplicity on handling a Snowflake, the simplicity that offers by the Snowflake, that is the major advantage. Okay. Yeah. Yeah. So any other questions? Okay. Okay, so this is a. Yes, yeah, we'll talk about the store JavaScript based stored procedures, and since I'm expecting for you to have some SQL knowledge, because we are not going to discuss the SQL from the basics, we are going to. I'm going to assume you have some kind of knowledge on SQL. Okay, so we are going to talk about the UDFs and stored procedures and all the complex topics in our session. Okay, so in Snowflake you can able to write the UDFs in 4 languages. You can able to write the stored procedures in 5 languages. Not only the SQL, apart from SQL, you can able to write the UDFs in Python, JavaScript, Java, and you can able to write the stored procedures uh, not only in SQL, also in JavaScript, Python, Scala, and Java. Okay, so like this we are going to mainly focus on uh, UDFs on SQL and Python. Okay, because Python is known for like Python is considered as a friend, okay, a friend for the data engineer, right? In any kind of data related project, Python is being used. Okay, so that's why. So for the UDFs we are going to talk about SQL, Python, and I would show you how to create a JavaScript based UDF. Okay, so if you know the Java and like that, I would show you how to create Java UDFs also, the syntax for it. Okay, and coming to stored processes, we are going to talk about SQL based stored processes. In Snowflake we call it as Snowflake scripting. Okay, and JavaScript based stored processes also we are going to cover. And stored processes related to Python, you need to use a new development framework called Snowpark. I would give you one example, but not okay, you need to explore additional on that. Imtiaz, did I answer your question? Yeah. Okay. So we have talked about what is data warehouse and what kind of features a ideal data warehouse should have, and the data warehouse evolution. Let's come to the Snowflake. Okay. So here Snowflake is a cloud-based data warehousing solution that can able to, okay, that can able to host on all three major cloud platforms, that can able to host on all three major cloud platforms. Snowflake is provided as a SaaS offering. Okay, so software as a service, so that can be deployable on all three public cloud platforms. That means whatever your cloud footprint may be, okay, you can able to plug and play Snowflake for the data warehouse purpose. Okay, so you don't need to disturb your existing data architecture that you are maintaining. So instead of Redshift, you can able to put Snowflake. Instead of Synapse, you can able to put Snowflake there. So that gives you the major advantage for the Snowflake. So that Snowflake can able to target all the customers that are present in these public cloud platforms. And when compared to these three, okay, when compared to these three major cloud players, okay, so, the data warehouses that is offered by these three public cloud platforms, Snowflake delivers the better performance, the simplicity, the ease of use, and more customization, all the things. Okay, all these are advantages for the Snowflake. Okay, so how it can able to handle all of that is based upon its unique architecture. So this diagram indicates the Snowflake architecture. So this is where the platform layer, also called as cloud agnostic layer, where you can able to deploy the Snowflake instance on all three major cloud platforms. The Snowflake is supported. Upon this, once you deploy Snowflake on a particular cloud platform, it is going to, okay, leverage this database architecture called, okay, multi-cluster shared data architecture in order to store your data and manage and process your data. Okay, in order to store, manage, and process your data as per the as per your requirements. Okay, so Snowflake architecture, so let me give you brief introduction. So in our regular sessions we are going to spend nearly 4 to 5 hours on this architecture itself. Okay, there is at least couple of questions on this in interviews. Okay, couple of interview questions directly on this architecture itself. Okay, so that much importance is there in order to understand about the Snowflake architecture. Okay, and a Snowflake architecture. In with respect to certification, you would get around 20 questions out of 100 on this architecture itself. Okay, so Snowflake has given lot of weightage in order to understand this story, understand the database architecture of the Snowflake in much uh, okay, a granular level. Okay, so here this is a three-layer architecture. The first layer that you see is centralized storage layer where all of your data is stored. So would act as single source of truth for uh, as per the organization, single source of truth for the data purposes that your organization is going to need, and whatever the data that you are going to store here in this layer is going to be okay processed by using this compute layer. So whenever you issue a query to the Snowflake, okay, so whenever you issue a query to the Snowflake, that query is going to be executed in this compute layer. Okay, so what is the uh, okay, what is the advantage of the here is Snowflake is, since it's a SaaS based offering, it does not offer you any kind of infrastructure. It leverages the underlying cloud providers infrastructure in order. Okay, so in order to store the data, it uses okay a cloud blob storage service. So what is the cloud blob storage service for for AWS? S3, right? So it uses S3 in order to store the data. Okay, this S3 is completely managed by Snowflake. This S3 is completely managed by Snowflake. So you cannot able to access this S3 where Snowflake is maintaining the data outside of the Snowflake. Okay, in here inside the Snowflake platform also, the only way for you to interact with this S3 service is via SQL only. Via SQL only. That kind of security compliances Snowflake supports. So Snowflake supports HIPAA compliance, PCI compliance, FedRAMP, SOC 1, SOC 2. All these data regulations are supported. So that much security you are going to have for your data when you maintaining in this centralized storage layer. Okay, so after storing the data here, whenever you issue a query that, so it is going to this compute layer is there, right? So it is consists of the compute service that you do have on that cloud. What is the compute service that you do have on the AWS? EC2, right? EC2 instances. Okay, Snowflake leverages these EC2 instances in order to process your data that has been scanned from your S3. Okay, that has been scanned from here from the storage layer. Okay, so as per your query requirement, only the data that is that that satisfies this query only would be scanned from storage layer to compute layer, and this a group of EC2 instances is going to be group of EC2 instances are going to be processing the data in order to deliver the result for you. Okay, so here for these two layers, Snowflake is leveraging the underlying cloud providers. That means in order to store the data, S3 and EC2. Similarly, for Azure, okay, blob storage accounts are there, right? Azure blob storage accounts or Azure Data Lake, like this kind of service, blob storage services are there, right? Okay, so it leverages that blob storage service from the Azure in order to store the data, and uh, virtual missions. Azure virtual missions are used to okay, to process the data. Similarly, the same thing. Okay, GCS is where Snowflake stores the data. If you host your Snowflake account on GCP platform, and similarly, Google's own virtual machines are there, right? So that is used for processing your data. Okay, and where Snowflake, so in these two layers, Snowflake is leveraging the underlying cloud providers infra only. Okay, in order to work as a fully managed data warehousing solution, Snowflake is going to be orchestrating on how to interact with each layer. Okay, how each layer interacts with other layer is orchestrated from this third layer called service layer. This service layer is nothing but a group of service clusters that are hosting Snowflake software. Okay, that are hosting Snowflake software. This through this cloud service layer, it provides lot of services like a query optimization service, the infrastructure management service, the transactional management service. This is because of this service you have the ACID compliance. Okay, and a lot of services related to the security and governance. Okay, and also the metadata is also managed from this layer itself. So Snowflake metadata is maintained in a foundation DB FDB. Okay, so that is going to be hosted on this EC2 instances, service instances. Okay, service clusters or whatever you call it as. Okay, and also via this one only you can able to share the data. Snowflake has a unique way of sharing the data. So in order to collaborate with other customers or other accounts that you are having, okay, your client is having, so in order to collaborate with them, so you can able to, Snowflake has been providing a unique way to share the data. Okay, so um, this cloud service is known as a brain of Snowflake because here everything is orchestrated from this layer itself. How to, which data that needs to be scanned, that needs to be scanned from storage layer, and how to parallelly process, okay, that particular query, and everything is every instruction is sent from this services layer only. So service layer is called as brain of Snowflake, this is called muzzle of Snowflake, and this is called um, okay, the storage, the single source of truth where you are going to maintain. Okay, yeah. Okay, so that is little introduction towards the storage architecture, not storage, the database architecture of the Snowflake. Okay, so Snowflake is a cloud-based. Okay, Snowflake is a cloud-based relational data warehouse that you do have that can able to be hosted on all three major cloud platforms. And whatever the traditional data warehouse features that you usually have, SQL-based data warehouse features that you usually have, all those features the Snowflake would also support. Okay, so apart from those standard features, Snowflake offers a huge array of additional features. Okay, so first one is Snowflake can be hosted on multiple clouds, like these three clouds. Snowflake cannot be hosted on okay, like private clouds or on premises. It cannot be done. Only public cloud platforms, that is AWS, Azure, and GCP. AWS, Azure, and GCP. Okay, so just give me a second. Let me have some water. Yeah, yeah. Okay, Snowflake is having one. Snowflake is the one of the data warehouse platform that you do have in the market with very cost-effective storage. Snowflake stores the data in the blob storage service, right? And you know that blob storage services are the cheapest storage that you do have in the market. So, in order to store the 1 TB of data, okay, for month, it is going to cost you around $20. Okay, so within this $20, your data, okay, the fault tolerance, the data replication, and everything is included. Okay, so you don't need to worry about any kind of okay, the data security, in order to provide disaster recovery setup, the fault tolerance, that kind of thing, you don't have to worry about anything. So in order to store 1 TB of data in Snowflake, 1 TB of data in Snowflake for month, you have to pay $20 itself. Okay, which when you consider with the other like traditional systems or other data warehouses that you do have, this is a very cost effective. Okay, so very cost effective, and Snowflake uh, guarantees that it compresses at least 3.4 times. So let's say you have 100 TB of uncompressed data. When you try to migrate this 100 TB data that is present in some of the, okay, some traditional data warehouse, you wanted to migrate it to the Snowflake. Snowflake guarantees you 3.4 times of compression. It guarantees that. So that means when you migrate from this source system to Snowflake, your data is going to be around 30 TB only. So you only have to pay for this 30 TB. Okay, you only have to pay for this 30 TB only. Okay, so this is not my number. Snowflake itself has stated this level of compression that it does on the data that you are going to store in the Snowflake. Okay, so that is the reason why Snowflake is having one of the cost effective storage, and Snowflake has a unique feature like time travel, zero copy cloning, and like this kind of thing. So what is time travel? So time travel in general terms, you know that you can able to travel back in time, okay, to a specific point in the time, and also you can able to travel forward in the time to a specific time in specific point of time in the future. So with respect to databases, going into the future is not possible, right? Okay, so the time travel with respect to Snowflake is you can able to query the data, whatever the data that is present in a particular table or a particular database at the sometime in the past. Okay, at the sometime in the past. That's what time traveling. For example, you have a table. Let's call it as table T1. Okay, and let's say on 1st February, on 1st February, on this table we have like 100 million records are there, and later that you have done lots of changes to that, and okay, a lot of changes to that, and currently on 27th February you are having like 110 million records are there, and you have changed, like added some derived columns to that particular table, like that you have done lot of changes to that table. So whenever you are on 1st February, uh, if you run select star from query, okay, select star from table T1, if you run that, whatever the current state you have, it is going to retrieve, it is going to return those results. That means 100 million records. And if you run the same query here, it is going to give you that 110 million records. Okay, so my requirement is whatever the transformations, whatever the development that you have made from 1st of February to 27th February, so this is not valid due to some kind of error bug in your code. You wanted to go back to the data that is present on 1st of February. Okay, so here with a traditional or legacy systems, you need to restore that particular backup and all of that, right? So that means in order to do that, you have to take a backup, okay, and maintain that backup for this many days. Otherwise you cannot able to restore that. With Snowflake has internally maintaining this historical data for up to 90 days. You can able to maintain that. Okay, up to 90 days you can able to maintain that. So by writing a single query, okay, single query, that single SQL query, so with some additional okay, with some additional syntax, so at timestamp, so I wanted to go back to 1st February. Okay, so by writing this simple query, you can able to access the data that is present in the 1st February. Okay, so that means with this particular time travel feature, you can able to query the data that is present in that particular database up to 90 days in the past, up to 90 days in the past. And for that you don't need to do any kind of thing. Automatically Snowflake maintains this historical data. Okay, so till how many days that you wanted to maintain that historical data can be managed by one parameter. Okay, one parameter called data retention time. So if you specify that parameter value as 30 days, okay, so these changes is happening on the table, right? So those changes are going to be stored within your system for 30 days. So since it is storing these additional changes, right? So in order to store this, maintain these changes, so additional storage requirement is required, so you have to pay for that storage cost. So and Snowflake has a intelligent way of minimizing those costs also. Only the change data only it is going to maintain. Okay, so not the entire data, not the entire snapshot of that every day. It is not going to maintain like that. Only the change data only it is going to maintain in such a way that it can able to optimize your storage costs also by parallelly providing this kind of new feature, like querying the any kind of past data over 90 days. Is it clear what is time travel? Okay. Next, Snowflake database is a clonable database. Okay, so what is clone? Okay, cloning. If you are okay, if you know, yeah. So it's exact replica of the original. Okay, right? So exact replica of the original. So here with Snowflake uses this zero copy cloning strategy. Okay, so whatever the data that you have in particular, let's say we have a database called db1. Okay, db1. So in this particular database, let's say 30 tb data is there. Okay, so and let's say, so this database that you are having. Okay, so you are migrating that particular database, or you are replicating that particular database, let's say from DB2 to, okay, so don't want to confuse with names. DB2 is a source system, that is offered by the IBM. So let's say some Redshift. Okay, Redshift. So here there is one particular database that is present in this Redshift, and you are replicating that particular database to the Snowflake. And in Snowflake, you named that database as a database one. Okay, that contains 30 TB of the data. So in order to test and development the pipelines and everything, so you need to have the same. Okay, in order to build the pipelines and everything, you need to have the same data in the lower environments also, if that is the requirement. So you don't need to maintain exactly the same data. The sample set of the data is also sufficient. But if you want to have the same, okay, so you want to have the same set of the data like your production database, so to the lower environments also. So what you need to do, you need to replicate this database into the lower editions, like this can be like your testing environment, so QA or UAT environment, let's call it as testing, and dev environment, let's say three environments are there. So if you wanted to maintain this lower environments also with the same data, so there are two ways. Okay, with traditional systems there is only one way: physically copy the data. That means physically copy the data from production to testing environment and dev environment. That means in your entire account, okay, in your entire account, so you are maintaining three databases of 30 TB of that. So that means 90 TB of the data, 90 TB of the data you have to pay. So that means out of all this 90 TB, 60 TB is, okay, redundant storage, right? Okay, only unique data is 30 TB only. Remaining 60 TB is the duplicated data itself. Okay, in order to provide the data for this different isolated environments, okay, you are replicating that. Snowflake has found a way with this zero copy cloning. Instead of physically copying this 30 TB data, it is going to let you copy the metadata related to this particular database. Okay, metadata related to this particular database to this let's call it as db1 testing, db1 dev, to these databases. Okay, so whatever the metadata that is associated to your production database db1 here, so it is going to, this cloning is going to copy the metadata related to this database db1 to this db1 testing, db1 dev databases. So by using this metadata, all three databases is going to be referencing a single copy of 30 db, single copy of 30 db. So zero copy cloning is like taking a snapshot of the, taking a snapshot of the, okay, source object, and make that snapshot available for the cloned object. Make that snapshot available for the cloned object. Okay, so here from the time the cloning has done completed, the source object is there, right? The source object and this cloned objects are two independent databases, two independent writable databases, which is very important. Writable databases. Okay, so that means whatever the from the point after the cloning, whatever the changes that you do to the source object, those are local to this source object only. Whatever the changes that you do on this cloned object, those are local to cloned object only. So in that way, while it is being cloned here, in your account you would have only 30 TB data only. 30 TB data only. You don't need to pay the extra storage. Okay, so storage cost. So that is, since there is a zero amount of data that is being physically copied, so that's why its name called as zero copy cloning. Okay, so only the metadata is going to be cloned. Metadata is going to be cloned from source object to cloned object. Okay, and after that cloning, each of these are both writable databases and can able to handle the changes locally. Okay, locally from each other. Okay, so in that way you have a single source of the data. On that you can able to do the changes as per your requirement. So in that way you can able to maintain the three different environments under a copy of single data. Okay, dev environment, testing environment, and production environment, by using a single copy of the data. Okay, and in dev, let's say suppose you have changed a particular table's data. Okay, so that change is local to the database only. Okay, so how it is possible you would understand once we discuss the snowflake database architecture. Okay, so everything would be clear at that time, how snowflake maintains this locally, and everything you are going to understand once we discuss that storage, this architecture. Okay, any questions regarding this zero copy cloning? So with this example we have talked about database, right? The same applies for table also, schema also. Okay, like that. Any questions? Okay, Snowflake is a really fast database. Okay, so Snowflake has a state-of-the-art query optimizer that can able to okay, so that can able to use the metadata that is storing here in order to rewrite the query automatically itself. If this optimizer would rewrite the queries automate with the consideration with the automatic join order optimization. Lot of optimization techniques internally it is performed by this particular service. And apart from that, how Snowflake stores the data in the storage layer adds the additional performance advantage. And also you have the scalable compute layer. Okay, scalable and elastic compute layer. Okay, so that enables the Snowflake to be one of the okay, so one of the better performant data warehousing solution that you do have in the market. So Snowflake stores the data in a form of micro partitions. This micro partitioning way of storing the data delivers the better performance than any of the traditional systems. Okay, any of the traditional systems. With addition to that, Snowflake does the query optimization here, and also combined with this unlimited scalability of compute resources with the elasticity that you need. Okay, so like horizontal scaling out and everything you have, right? So by leveraging this kind of different at each layer it is adding some kind of performance optimization technique in order to run that particular query much faster. Okay, in much efficient way. Okay, in much efficient way. And Snowflake is a really elastic data warehousing solution. Okay, hyper scalable and hyper elastic data warehousing solution. And Snowflake currently it's a okay, so the petabyte scale kind of databases that you can able to maintain in Snowflake. Under Snowflake currently multiple hundred exabytes of the data is managing under the Snowflake. Okay, so that means uh, how much is exabyte, like one exabyte equal to 1024 petabytes. Okay, so nearly under the Snowflake organization, there is hundreds of exabytes that it is managing currently. Okay, it is managing currently. And whatever the databases that you are going to maintain in the Snowflake, these databases can be petabyte scale. Okay, petabyte scale. 1 petabyte equal to 1024 terabytes. Okay, so as far as I know, you can able to. There is a Micron system that is maintaining 40 TB of data. Okay, 40 TB of data. Like that, there are particular, not TB, petabytes, PB of data, 40 petabytes of the data. Okay, so there are some clients that are maintaining hundreds of petabytes of the data in their system. Okay, and also Snowflake does not put any kind of hard limits. You can able to, under single Snowflake instance, you can able to maintain as many databases as you'd like, and each database may contain as much of data that you would like. Under each database you can able to maintain hundreds of schemas also. Inside each schema you can able to maintain hundreds and thousands of tables also. And under each table you can able to, each table can able to hold even petabytes of data also. Okay, so Snowflake is truly a petabyte scale. There is no limit, any kind of hard limits with respect to how much data that you can able to manage under a Snowflake database. Okay, so let's say one of the Snowflake customer is maintaining like nearly 60 trillions records in a particular table. If you take that table to be on an average like 40 to 100 columns, 60 trillion records would accompany 1 or 2 petabytes of the data, 1 or 2 petabytes of the data. Okay, so that much scalability and that much elasticity that Snowflake is offering. Okay, and Snowflake is a semi-structure ready. Okay, semi-structure ready database. That means you Snowflake provides you, in order to store the semi-structure data directly into the Snowflake. Snowflake provides you a okay, Snowflake provides you a efficient data types, efficient data types in order to hold this semi-structured data, in order to hold the semi-structured data. Currently Snowflake supports JSON, XML, Parquet, Avro, and ORC. So these are the from the Apache ones. Okay, so these are the data for semi-structured formats that Snowflake supports. In order to store the semi-structured data, Snowflake provides efficient data types like variant, array, and object. These kind of data types, and whatever the data that you have stored here in the semi-structured format, you can able to query by using the SQL syntax. By using the SQL syntax, for that SQL syntax is Snowflake provides some extended SQL syntax. Okay, so by using that extended SQL syntax, you can directly query this semi-structured data with your traditional SQL based syntax. Okay, so this extended SQL support is for, it provides some built-in functions. Okay, built-in functions and commands in order to query this extended query the semi-structured data. Okay, so we are going to talk about this semi-structured data very elaboratively. Okay, so how to load it and how to directly query the data, and what are the different techniques that you do have when you are loading the data and everything. Okay, and coming to the shareable, Snowflake is a shareable database. That means whatever the data that you are maintaining in the Snowflake database, that data can be shared to the other customers. Okay, other Snowflake customers. Let's say you have, your business is having some kind of agreement in order to share the data to the subsidiaries or to the other organizations. They have some kind of contract obligation is there, and you wanted to share the data. So if that is the case, what is the way that you do have? So you need to segment the data first. that you wanted to share with that particular customer. Okay, so you need to segment the data, extract the data, and place it in a secure FTP server. While doing so, you need to compress the data. Sometimes for the security purpose, you also need to encrypt the data. Once the data comes into that particular FTP server, you are going to give access to that particular customer in order to uh, access this shared data, right? So that particular customer needs to extract, like download the data from the FTP server, build ETL pipeline so that this data can be, okay, so that this data can be merged with their own business data. Okay, so this is a very lengthy process. How much streamlined this can be? It would take couple of hours to get the data from this end to the consumer end, right? So here you are not having a there is no option for you to share the live data. Okay, with the Snowflake data sharing, okay, instead of physically moving the data from data provided to the data consumer, Snowflake has a intelligent way of sharing the data. Okay, so instead of physically moving the data, it's by using its a patented data sharing architecture, it shares only the metadata that is related to the tables or objects that you wanted to share to that particular data consumer. So whatever the metadata that associated to that particular table that you wanted to give access to that particular data consumer, so that data metadata is copied from your account to that particular data consumer Snowflake account. So in that way, since he has all the access to that particular table, he can able to query that data, or he can able to read the data that is present in the table. So here, okay, so here, let's say this is the data provider, my account. I wanted to share the data to you, so call it as data consumer account. Okay, data consumer account. So here, in my account, there is a database called db1, and there is a table called t1, view called v1, and another table called table 2. So these three objects that I wanted to share to you. So whatever the metadata that is associated to these three objects that I am going to that I wanted to share to this particular data consumer. Okay, so with those metadata, I'm going to share the details to this account. Okay, so by via feature called data share. So here you need to create a share object. So via this share object, you are going to share the details regarding the access to these tables. Okay, so all of those things are shared via this share object. So with this share object, he is going to create his own database in their account, call it as db. Okay, so db1 share. Okay, so here, in this account, you don't have, actually data is present in my account. So let's say this contains 1 TB data, this contains like a 500 GB, and this is a view. Okay, so that is referencing a few other tables and like that. Okay, so all of this data is stored in our account. When he creates it, there is zero amount of data that is going to be stored, 0 bytes. Okay, so whenever you query this, okay, whenever you return a select star from this table, okay, it is going to fetch the data from here, from my account, and gives him the result. Okay, so that's the okay, we are going to spend lot of time regarding this data sharing. So in 5 minutes I cannot make you understand, but here you don't need to physically share the data. Physically copying the data is not necessary. Only the metadata is shared to this particular data consumer, and by doing so, you are giving read only access to the data consumer. For this table, he cannot able to do the DML operations. Only whatever the data is present there, he can only read the data. And also the live access you have given. Okay, let's say if I to this table 1 I have inserted like 10 million records. In this very second, once that particular transaction is committed, in the very next millisecond, he can able to access those additional 10 million records also. That is the live data. So in this data sharing, Snowflake provides three products. Okay, so that is direct share, private data exchange, and public data marketplace. Okay, so we are going to talk about all of this. Okay, so direct share is for when you wanted to share on one-on-one basis. Private data exchange is for when you wanted to share from one account to many accounts, whereas a public data marketplace is like our Play Store. Okay, many Snowflake accounts can able to publish their listing that can be accessible by all the Snowflake accounts. Okay, so just keep this information we are going to talk about during our sessions. Okay, so whenever someone asks you what is a Snowflake, what is the new, what can you tell about the Snowflake, try to answer it like this. Snowflake is a cloud based data warehouse that can be hosted on multi cloud platform with very cost effective storage that has unique features like time travel, zero copy cloning that can able to really um, scale hyper elastic and hyper scalable and also really fast database. Okay, and that is also supported semi structured data, and it has a unique way of sharing the data to the other Snowflake accounts. So in that way you can ask. And there is also Snowflake provides a automatic data replication in order to promote the business continuity. So in case your primary instance goes down, your business would impact, right? Okay, so in those cases you can able to maintain the disaster recovery accounts. So in that case you can able to promote that disaster recovery account as your primary account, so that your business won't experience the downtime. Okay, so for that automatic data replication is also supported. So uh, what are the advantages of Snowflake is with Snowflake you can able to whatever the your current data stack is there, you can able to use the tools that already has. Snowflake has a very rich ecosystem that can able to complement the integrations with all of your okay existing data stack, the tools and upstream tools and downstream tools, it can able to support everything. Okay, and you can able to develop with the languages you already know like SQL, Python, Java, Scala, JavaScript. Okay, and Snowflake supports you in order to modernize your data stack in order to make some data driven decisions on like AWS SageMaker. Okay, data robot, H2O, and these are the machine learning data science related objects. And for the streaming data, it also has a connector for Kafka and all of this. Okay, so another advantage of Snowflake is you can able to host Snowflake on any cloud you want, and you can able to work with any data that you need, structured, semi structured, or unstructured data. Even the shared data also you can able to build your data products on. Okay, so that is about what is Snowflake and like that. So okay, so whatever your data sources may have, okay, so this enables Snowflake enables the organization in order to eliminate the data silos that present in their business data by unifying the existing data warehouse, data marts, and even data lake also you can able to build inside the Snowflake. Okay, so in order to make a single source of truth, in order to make a single source of truth, whatever the data sources that you may have, this can be transactional or operating systems like RDBMS based NoSQL databases or like this kind of thing, or enterprise applications like okay, CRM, CRPs, Salesforce, this kind of thing. Okay, or some third party data or web applications, whatever the data source may be. So either using ETL or ELT, so you can able to load the data into the Snowflake. And in Snowflake you can able, so far we have talked about the data warehousing one only, right? In Snowflake you can also able to build the data lakes also. Okay, data lakes also in order to support a data lake plus data warehouse. Okay, so in Snowflake lets you to build the data lake also, so where you are going to store the data in a raw format, and cataloging that files the cataloging the data that is maintaining this data lake via using a directory tables. You have that kind of concept in Snowflake. Okay, so upon this data, your data lake that present here, and you can able to build a enterprise data warehousing solution, and from that enterprise data warehouse solution you can able to build the logical data marts that serves to the particular group of users that you do have. So, and your analytics teams or business teams can able to leverage this data in order to make some data driven decisions. Okay, so in order to make some data driven decisions. So that is what Snowflake is. With Snowflake you can able to build data warehouse, you can able to build data lake, and you can able to build the data engineering pipelines. Okay, build the data science related applications and the data applications, so that the customer users can able to access those applications in order to live querying the data that is present in your data warehouse. Okay, and also with Snowflake a unique data sharing architecture, you can able to collaborate with other customers also. You can able to collaborate with other customers also. Okay, so like all of this with Snowflake, recently it has launched another, uh, recently launched another workload called as Unistore. It is a OLTP workload. Within the Snowflake system itself, you can able to maintain the transactional data also. So with this, with the addition of this Unistore workload, you have both analytical data and transactional data under a single platform called Snowflake. So that would make you do the real time, make you perform the real time analytics. Okay, so for that Snowflake is bringing this particular workload called Unistore, which is a OLTP workload, so with Snowflake you have one platform, one copy of the data that supports these different many workloads. Okay, all the data is secured and provided access to all. Okay, that can able to deliver the virtually unlimited performance and the scale. Okay, and Snowflake is a near zero maintenance platform that can be delivered as a service. Okay, so sorry, I'm a little bit going fast. So because I have class at 7:30. Okay, so they are waiting for me and they are sending the messages here. Yeah, please go on. Mm, yeah, yeah. So, no, 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 no. Snowflake has its own storage layer. It's not on top of the data lake or like that. Okay, yeah, so it's Snowflake has still in. Yeah, okay, yeah, okay, I'm just sending the message to that other batch. Okay, yeah, so please go on with your questions. Sorry, a little bit distracted there. Yeah, no, no, no. No, it's not. So if you have a data lake, you need to move the data from the data lake to Snowflake. Okay, so it's not on top of the existing data lake. Okay, so you have to move the data from your existing external data lake. Okay, but as per this particular diagram you can see, right, you can able to build the data lake within the Snowflake also. Okay, so you are going to usually for most of the projects you are going to have external data lake. Okay, so like that can be on AWS S3 or ADLS Gen 2. or GCS. Okay, so whatever the your existing data lake, when you wanted to maintain that here, you need to move the data from here to Snowflake. Physically move the data. Okay, physically. Okay, so if you want to maintain the data lake within the Snowflake, so now it can able to act like what you said. Okay, it can able to provide the security and governance layers on top of this data lake, where you can able to catalog the data and everything. Okay, I hope I answered your question. Yeah, this is also working on. So yeah, so Snowflake here the data, the locking mechanism is at partition level. So that partition, you call it, you can think it as a file. Okay, so in since it's a blob storage, the data is going to be stored in a form of files, and Snowflake has a proprietary file format. Okay, file format in order to store the data. Okay, so here the locking is happening at the partition level, at the column level. The more granular level is at the column level. Okay, because Snowflake is a column level columnar database, right? So yeah, yeah, nice questions, by the way. Yeah, yeah. So any other questions? Okay, so sorry to take such a long time. I hope you are getting some valid points here. Yeah. Okay, so here this is the end-to-end architecture which I've been talking about for last 30 minutes to 1 hour. Okay, so from whatever the data sources that you do have, so usually you are going to have some established extraction pipelines from these different data sources to the your existing data lake. If you don't have the existing data lake, you may have to build the extraction pipelines to the cloud. Okay, so where from there you are going to ingest the data into the Snowflake. Since Snowflake supports the ELT framework, so you are going to load the data into the staging layer. So from once the data is staged here, okay, so if you are maintaining a data lake inside the Snowflake, then you are going to move that files for the as per the data lake workload. You are going to maintain that raw files in the data lake repository, where you are going to maintain within the Snowflake. If it is you are having external data lake, this particular layer is not required. Okay, so you can directly do the transformations on the Snowflake in order to do the data cleansing transformations and enriching the existing data model that you do have, and finally store the data into your consumption layer, where these data is accessed by this multiple business teams, analytics teams. So upon on top of this data, Snowflake maintains lot of metadata and provides additional layer of security and governance. And also Snowflake provides some kind of monitoring monitoring features also, by giving you access to some metadata based views that it is maintaining uh, in the separate database called Snowflake. Okay, so this is what the Snowflake or your job, most probably your responsibility would involve as a Snowflake data engineer in this area. So if you have some kind of ETL experience, so in that case, if you are a experienced data professional, then you need to handle this kind of area. Okay, so this is for Snowflake data engineer. Okay, this is for cloud data engineer. Okay, and there is okay there is a newly recented profile classification is there, analytics engineer. Okay, so where you need to have the some kind of business intelligence tool also you need to have. Okay, so like this analytics engineer, so based upon your experience, prior experience, total working experience, so you may have to work, you may have to assume any one of these roles. Okay, on that particular project. So Any questions? No, no. So yeah, so here you see this, right? Foundation DB. So this Foundation DB, it's a shared database. Okay, basically, so whatever the um, okay, so whatever the accounts that Snowflake is being issued in a particular cloud region. So for for the all those users, Snowflake is going to maintain a shared metadata okay, metadata database where the metadata is stored. So that database which stores the metadata is called as Foundation DB, which is a NoSQL database. You may know that. Okay, so it's a key value store. Okay, key value NoSQL database. Okay, so here whatever the fault tolerance that you would expect for a that you would expect for that uh, for NoSQL database, all of them would have here. So there is a disaster recovery complaints would be there, fault tolerance, the data availability and data durability, all the things that you usually would have for a NoSQL database, all those would also be applicable for this Foundation DB. So internally, it's not a single, like you said here, that metadata is not stored in a single version. Okay, so here the metadata is maintained in the multiple instances also. So there is a concept called availability zones. So in each availability zone, the same metadata would be replicated. Okay. Yeah. Yeah. No, not a problem. Yeah. So there is a concept called availability zones in Snowflake. That means in order to make the data highly available and highly durable, so whatever the data that you are maintaining in the Snowflake is going to be replicated to three availability zones. Okay, so continuously this kind of replication is there. Even if this goes down, these two availability zones would be uh, alive. So unless you expect a region level failure, okay, so like during natural disasters at that time, so no one can able to do at that time, right? So for that you need to have so cross cloud, cross region disaster recovery setup, so which we are going to discuss in the session also on how to set up this everything. Okay. Yeah. Yeah, Snowflake, the market is very good. If you go to, okay, even if I say that, you may not believe it, but from what I know from last 6 months, there is hiring freeze that is going on. For some technologies, there is zero calls. Okay, so for Snowflake, most of my who are active in our sessions, all of them has been already placed. Even for running batch also, one person has got recently placed in EY. Okay, so there is continuous requirements are there for the Snowflake. Okay, you just put some kind of fake resume and you would expect the calls to be rushing your way. Okay, so there are huge scarcity for the Snowflake resources in the market. But the level of interviews has been the toughness of the interview has been like exponentially increased, before 8 months. Okay, so with the basic simple questions, even this demonstration with this demonstration you can able to answer like 60 to 70% of these questions. That much simplicity the interviews has been there. But now they are trying to evaluate on all fronts, not only from Snowflake, on the SQL front. And even if you put Python also, they are spending some like 25 percentage of time on Python also, if you put Python in your project, because Python is known as okay, data engineers programming language, right? So that's why there is a lot of requirement for Python skilled resources. So there are lots of opportunities, but you need to have the right skill. Okay, so you need to know about the how to write a queries for the real time scenarios that they are going to ask you in the interview sessions. If you can able to do that, there are huge number of opportunities, I can guarantee that. Yeah. No, it's not the freshers. Yeah, it's not for the freshers, because okay, so in order to work on Snowflake, you need to have the data warehousing concepts and all of that. Okay, and also you need to have the cloud based concepts and all of that. Okay, and apart from that, so Python and all of this, not a fresher does not have, typically does not have all this kind of skill set. So that's why it's not for fresher. But if you have 2+ years of gap, then you can go in that way. Okay. Then there would be calls, there would be calls. Yeah. Yes. Yeah. Okay, so I have multiple slides that would demonstrate this end-to-end architecture, how to extract the data from here and how to load it and everything. So anyway, we are going to see the same steps. Okay, so during our data ingestion chapter. Okay, so okay, so let me show you the course curriculum that we are going to offer. Okay, so this is 2 months. It would take 2 months. Yeah, it's opening up. Yeah. So during this like 60 hours, not 2 months, guys. So since it's the evening, I can able to take per day 1 hour 15 minutes and 1.5 hour also. So here I have divided the topics that we are going to discuss here for 3 modules. In the first module, we are going to start to know about what is Snowflake. Okay, how to set up the practice trial environment, lab environment, and everything. So while doing so, what kind of decisions that you need to make, and also discuss about Snowflake certification if you are interested in such kind of thing. If you are a working professional and you wanted to make a career transition to the Snowflake, the best way to um, approach the job market is getting certified in the Snowflake after training. So getting certified in that. So with this training, I can guarantee that you can able to crack that if you follow each and everything that we are going to talk about. So this would make you this training course would give you 2+ years of expertise on the hands-on expertise on the Snowflake, along with the certification related things we are going to you can able to clear the certification also. Okay, so then after setting up the trial environment. Okay, so how we are going to discuss what are the different ways that you do have to connect with that trial account, and what is the Snowflake ecosystem, like connectivity ecosystem is there. So what kind of drivers, connectors it is providing, and what kind of with what kind of tools there is established connection that has been already implementing in the real time by some Snowflake customers. So those kind of things we are going to I'm going to show you at this stage. And next we are going to talk about the system architecture, that is the Snowflake database architecture. Okay, so Snowflake follows hybrid architecture that has the advantages of both share disk and share nothing, and how it has implemented this new architecture by taking the advantages of these two architectures. We are going So in order to understand that, you need to have basic understanding about this share disk and share nothing, right? So little introduction towards those traditional MPP architectures, and then we are going to talk about the storage layer, the compute layer, and the services layer. And also, for any kind of cloud based tool, the pricing is very important, the billing aspect is very important. You need to understand which components would considered for billing. So you know, how do you optimize that, and how do you monitor that usage and everything, right? So we are going to talk about the pricing and billing point of view also. After that, so we are going to talk about the how to manage the SQL data objects. Okay, so the object hierarchy I'm going to show you, and so for that, So here you would see I'm going to share you a introduction to data warehousing concepts that would talk about the from diagram to okay the relation. Okay, so mm, the data modeling, the dimensional modeling, the star schema, snowflake schema, how you would maintain the data warehouse, whatever the theoretical concepts that you need, everything is included in this particular PDF. So this PDF contains 50 pages. So from the basic beginner can also able to understand. I have given that in with the examples also. So this would help you in order to understand the data warehousing concepts. Okay, and after that I'm also going to share you the SQL related SQL Oracle SQL related document, okay, a PDF also. Okay, and Snowflake related PDF which is not completely available till here I have prepared, so I'm going to share that also. But okay, so you have this SQL Oracle SQL notes also there, right? So please go through that. If you need any kind of document related to the SQL, so you can follow that. So these things we are not going to discuss. I'm going to provide a PDF for you. So from here onwards we are going to cover in our sessions like what are the different types of databases, in which scenarios that you follow that particular databases, okay, which database you would create, the different types of schemas, tables and their types, views and their types, and that kind of objects. Okay, and the performance optimization, so we are going to either discuss this at this stage or at the end of the course also, because performance optimization usually is a process that you do at the end after migrating and everything. So in order to improve the existing workload performance, so you are going to do the this kind of optimization techniques, right? So uh, this suits at the end only. Okay, so most probably we are going to discuss this after the data ingestion and transformations, building the data pipelines, and all of that is completed. Okay, so under this performance optimization, we are going to talk about virtual warehouse optimization and the data loading, transformation, and querying performance. So here, Snowflake provides a lot of its own techniques in order to improve the performance. We are going to talk about those. And okay, so the next module is the data ingestion and transformation in Snowflake. Okay, so here we are going to talk about what the different methods that you do have to load the data into the Snowflake, and what are the alternatives that you do have for the data loading. Sometimes you there is some kind of data that you don't want to directly load. Okay, so you wanted to have a feature uh, like redshift spectrum tables, like that kind of thing, or external tables kind of thing. Okay, so Snowflake provides okay, so Snowflake would acts as a okay like a querying engine in order to query your data lake also, in order to query your data lake also. So how to do that we are going to talk about. Okay, so here we are going to implement the data loading strategies, like these three data loading strategies and all of that. And in order to load the data, what kind of things that you need to know. Okay, so all of those things we are going to talk about. So one important thing is stages. Okay, so what are the different types of stages are there. Okay, internal stages and external stages. So we are going to talk about how to load the data from internal stages, and how to load the data from external stages, what are the different options that you do have. Okay, and everything we are going to discuss. Okay, so with respect to external stages, we are going to talk about the in order to load the data from AWS S3 to Snowflake, from Azure Blob Storage to Snowflake, whether that can be a legacy blob storage or uh, general uh, purpose version 2, or general purpose storage version 2, or ADLS, whatever it is. So what are the different ways that you do have available in order to load the data from Azure Blob Storage accounts to Snowflake, and also from GCS to Snowflake. And after that, there is a requirement for you to unload the data also, right? Some scenarios. So how to unload the data from Snowflake to this S3 buckets, and like that we are going to show you. Then we'll come to the continuous data loading. So continuous data loading is nothing but as soon as the data is generated, you wanted to load the data into the Snowflake. If that is the scenario, then you need to build the serverless pipelines that would do the data ingestion on the whenever the new data comes. Okay, so for that also we are going to talk about the different techniques. So from AWS S3 to from Azure storage accounts to from GCS. Okay, and whenever there is a error occurred while loading the data, how to handle that also we are going to talk about. And after that we are going to talk about the semi-structured data handling. Okay, and then build the data pipelines in order to transform the data. Okay, so for that we are going to talk about streams, we are going to talk about tasks and like that. And like I said, I told you alternative to the data loading, right? So here you would see the external tables are there in Snowflake in order to directly query the data lake from the Snowflake environment. So you can also able to we are also going to set up this and everything. We are going to discuss that. Next, the third module. So as a part of real time working, the second module is where more 80% of your job description would satisfy. Okay, so this is very important. We are going to cover like 25 to 30 hours in this second module itself. In the third module, we are going to talk about the continuous data protection features that Snowflake is having, like time travel, what is failsafe, cloning, okay, disaster recovery setup and everything. And next, the Snowflake secure data sharing, how to share the data. So like I said, there are three, right? Okay, direct share, data marketplace, data exchange. So how to implement this and everything we are going to show. And then the Snowflake programmability, user defined functions, stored procedures, and Python connector I'm going to show you. Okay, so Snowflake provides these two things. Okay, Snowflake provides the connector for Python and also the Snowpark framework for you. Okay, so these are the two libraries that Snowflake provides in order to interact with the Snowflake database from Python environment. And we are going to talk about Snowflake security. So what kind of infrastructure security, data security, what are the authentication, okay, network security, and what kind of object security, that means the data access strategy that Snowflake follows. Okay, so all these kind of security related things we are going to talk about. So role based access control and everything we are going to talk about. And next, the data governance related. So row level security via row access policies, column level security via dynamic data masking, and object tagging is also, if it is required, we are going to cover it. But usually there is nothing to, we just need to know how to create a tag and which cases that you are going to use this object tagging and like that. Okay, so the data governance related features also we are going to cover. Okay, so for column level security, there is external tokenization is there. So for that you need to have some kind of external application that would tokenize your data. Okay, so that is impossible for us to show you in our sessions. Okay, so that's why we are not talking about that. So this is the SQL way of implementing column level security, so that we are going to talk about. So if it is required, okay, usually many people don't ask us at this stage. Okay, if you want how to integrate BA tools with the Snowflake, I can show you that. Okay, by using the JDBs and ODBs drivers. Usually those drivers would be used in order to integrate, okay, these tools with the Snowflake database. And also, okay, the Matillion. Okay, so this would give you some kind of introduction towards the some ETL tool. This Matillion is a cloud-based ETL tool. Okay, cloud-based ETL tool. And you okay, cloud-based ETL tool that is offered as a software as a service offering. So you can able to work with okay, so this Matillion is suitable for a lot of cloud-based data warehouses. Okay, and this Matillion is named as continuously 5 years the best data integration partner for Snowflake. And in the market, if you have the Matillion skill along with Snowflake, then there is a lot of weightage for your profile, and there is lot of preference for you if you conduct the interview well enough. Okay, so that's what we are going to cover for next 60 hours. Okay, yeah. Okay, by the end of this course you would become comfortable in clearing the certification, snow pro core certification. So actually snowflake provides two kinds of certifications, the basic level and advanced level. Okay, so this is the basic level certification. Okay, so even this is more than sufficient for you to have edge over the other 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 interview people that are attending for that particular role. Okay, so my suggestion is please try to prepare for both certification and interview. Okay, so because certification nowadays, even you after joining that particular organization, they are asking you to get certified. Okay, so because they wanted to showcase the to the client that they have a skilled resources, right? So yeah, so that's about it. So sorry to take such a long time. Okay, nearly 2 hours. Yeah. So if you have any questions, please let me know. Yeah, thank you, brother. Yeah. I hope you enjoyed the session, and if you have any kind of questions, okay, so connect with our team. So our team is going to inform you when the regular sessions are going to be started. As I told you, there is a ongoing session that is at the very end. They have like 3 to 4 sessions that are left. Okay, so I'm going to manage them like by shifting to some other time, but I need to talk with them. So I'm basically I didn't know they have scheduled this demo session without asking me. Okay, that's why there is a confusion between the two batch for this one and the other people that been waiting in the other link. Okay, so sorry about that. So for a brief time I was distracted there. Yeah. Okay, see you guys. Yeah, thank you, thank you. See you in next session. Have a great day. Bye.